Good morning, beautiful humans. Today we are going to talk about the warm-up for 1.3. So we're going to look at this graph and we're asked to describe how it changes over time. So if we look at our graph here and I look at time, or typically my x-axis is how we think about things changing over time. So as I look along x, what's happening to my y values? So I go over to 2 at x and I'm up at 1 at y, and then over 3 up to 4. So we're growing. So for this section of the graph right here, we're increasing. So it seems to be growing, building over time. But then you'll notice on the second half, now we're falling. So this thing is increasing on the left and decreasing on the right as we read this graph left to right. So it changes over time, and that's the case for many types of functions. This one kind of looks like a quadratic, which we'll talk about in the future. Is it discrete or continuous? Okay, we talked about this. If you can trace the entire graph without picking up your pencil, then it's continuous. Well, clearly, if I were to go to trace this, I would start here, and then I'd have to go here. And without picking up my pencil, I would have that line in between them connecting those two dots. And that's not what this graph has given us. So this would be a discrete function or a discrete graph here. What could we label the x and y axis? Well, of course, there are a variety of options for what you could do for this. You could do something like if the x-axis was time in seconds, and maybe the y-axis is, I don't know, yards above the ground and as seconds after you've kicked a soccer ball or something. So that soccer ball goes up, and then of course what goes up must come down, so it comes down on the other end. Of course, you can come up with something else that would make sense as a model for something that has kind of a parabolic curve. It goes up and then comes back down. Hope that helps. Have a wonderful rest of your day.